AI chip manufacturing. Here is your same structured, beginner-friendly content for AI chip manufacturing, beginner level introduction. AI chip manufacturing is the process of designing and producing specialized hardware chips optimized for artificial intelligence workloads. Traditional CPUs are not efficient for AI tasks, so companies build special chips like GPUs, graphics processing units, TPUs, tensor processing units, NPUs, neural processing units, ASICs, application-specific integrated circuits. These chips are designed to process large amounts of data, perform parallel computations, run AI models faster, reduce energy consumption. Examples include AI chips in smartphones, data center GPUs, self-driving car processors, edge AI devices. This topic helps beginners understand how hardware powers modern AI systems. What is AI chip manufacturing? AI chip manufacturing is the process of creating specialized chips designed to run AI models efficiently. In simple words, AI chip manufacturing equals building hardware for AI. Key idea. Instead of general-purpose chips, AI uses specialized chips, specialized processing, specialized architectures. Types of AI chips: chip type, purpose, CPU, general computing, GPU, parallel processing for AI, TPU, AI-specific acceleration, NPU, mobile AI processing, ASIC, custom AI chips. Example of parallel processing concept: data equals 1, 2, 3, 4. For D in data, print D times 2. AI chips do this in parallel instead of sequentially. Example of AI computation: weights equals 2, 3. Inputs equals 5, 10. Output equals weights 0 times input 0 plus weights 1 times inputs 1. Print output. This is similar to neural network operations. Simple AI chip concept: Python. Def compute data. Return x times 2 for x in data. Print, compute, 1, 2, 3. How AI chip manufacturing works. Step 1. Chip design. Engineers design architecture. Design equals AI chip architecture. Step 2. Simulation. Test chip behavior. Print. Simulating chip performance. Step 3. Fabrication. Manufacture chip in factories. Print. Chip fabricated. Step 4. Testing. Ensure chip works correctly. Print. Testing chip. Step 5. Deployment. Use chip in devices. Print. Chip deployed in device. AI chips in data centers task equals train model. Print. Using GPU for training. AI chips in mobile devices task equals face recognition. Print. Using NPU. AI chips in autonomous vehicles. Task equals object detection. Print. Real-time processing. AI chips in edge devices. Device equals IoT sensor. Print. Processing locally. AI chips versus traditional chips. Feature: AI chips, traditional chips. Processing: parallel, sequential. Speed: high for AI tasks, general purpose. Efficiency: optimized, moderate. Use case: AI workloads, general computing. Full menu-based example: Def design chip. Print designing AI chip. Def simulate chip. Print simulating chip. Def deploy chip. Print deploying chip. While true, print N1 design. Print 2 simulate. Print 3 deploy. Choice equals input, enter choice. If choice equals 1, design chip. Elif choice equals 2, simulate chip. Elif choice equals 3, deploy chip. Elif choice equals 4, break. Else print invalid choice. Hardware acceleration, parallel computing, AI optimization, chip design, real-time processing, edge computing. Real-life analogy. AI chips are like specialized tools. XCPU equals general tool. XAI chip equals specialized machine. Ways to improve a project. Learn hardware basics. Study GPU programming, CUDA. Use AI frameworks, TensorFlow, PyTorch. Explore chip architectures. Build edge AI applications. Optimize performance. Study semiconductor design. Explore FPGA. Common mistakes beginners make. X. Thinking all chips are the same. X. Ignoring hardware limitations. X. Not optimizing models for hardware. X. Overlooking energy efficiency. X. Confusing CPU versus GPU roles. Where it is used: data centers, smartphones, autonomous vehicles, robotics, healthcare devices, IoT systems, cloud AI, gaming. Large systems may include GPU clusters AI, accelerators edge AI chips, cloud infrastructure. Simple definition: AI chip manufacturing, the process of designing and producing specialized hardware for running AI efficiently. Final summary: AI chip manufacturing enables C. Faster AI processing, efficient computation, real-time AI systems, scalable AI infrastructure. It is the foundation of modern AI hardware systems.